Hey guys, this is Professor Janacek. I want to go over some examples where we find equations of lines in three-dimensional space. Let's go ahead and get started. Example 1, we want to find the equation of the line through the point -3 to -1 and in the direction of the vector 1, -2, 0. So let's see. To begin with, I know that I've got I'll call it P naught, is this point -3 to -1. So remember, this is a point. Now if I want the vector in the same direction as that point, I'll call it R naught. R naught is the vector -3 to -1. Right? That's one thing we'll need. We also I want to make note that I'm going to have this equation in the direction of V. So let me just jot that down, 1, -2, 0. Now, if you recall, the equation of a line in 3 dimensions is R naught plus T times V naught. So in this case, that would be -3 to -1 plus T times 1, -2, 0. Of course, we can go ahead and write this in its component form. So all I'm going to do is I'm going to do the vector operations, multiplication and addition. It's going to be -3 times -3 plus T times 1 and 2 plus T times -2 and -1 plus T times 0. So the first component, we get -3 plus T. For the second component, we have 2 minus 2T. And for the last component, we have -1 plus T times 0, so that's just -1. And there we go. There is the equation of the line. I know it only slightly looks like an equation. It does have an equal sign, but remember, we consider these to be parametric equations. And you can say that this is a vector-valued function as well. All right, on to example 2. Let's find the equation of the line through the 2 points 0, 4, 8 and 10, -5, -4. First, let me go ahead and label one of those points as P naught. I will go ahead and make that the first point, 0, 4, 8. And so that means the vector, the related vector is 0, 4, 8, but now I'm using vector notation. All right, now for V, this is a little tricky. So it's not too bad though, don't worry too much. It's gonna start at point 0, 4, 8, and it's gonna end at 10, -5, -4. So again, my vector goes from one point to the other. So this V vector goes from the first point there to the second point. How do I write the components of that? Well, since I'm starting at 0, 4, 8 and I'm ending at 10, -5, 4, we have to write this in, we're going to do a little subtraction. It's going to be 10 minus 0 for the first component, -5 minus 4 for the second component, and -4 minus 8 for the third component. See how that works? And so, of course, we can simplify that. It's simply 10, -9, -12. So there's vector V. And again, our equation, R of T is equal to R naught plus T times V. So that's 0, 4, 8 plus T times 10, -9, -12. Put that together, R of T becomes 0 plus t times 10, so that's just 10t. 4 plus t times negative 9, so that's 4 minus 9t. And 8 plus t times negative 12, so that's 8 minus 12t. Not too bad. There we go. All right, example 3. Let's find an equation of a line through a point 1, negative 3, 4, and parallel to a line. R of t is equal to 3 plus 4t, 5 minus t, and 7 for its components. All right, well, let's see here. First off, we'll go ahead and label P naught 1, negative 3, 4, which gives us the vector R naught is the vector 1, negative 3, 4. Easy enough. Now, we want this equation to be parallel to R of t. Make sure that's clear. Is equal to 3 plus 4t, 5 minus t, and 7. Notice that this is equal to 3, 5, 7 plus t times 4, negative 1, 0. So notice what I did there. I kind of took the non-t portion of each component, 3, 5, 7, and that becomes that first vector. And then I took all the coefficients of the t's. Of course, the third component doesn't have a t portion, and that became the second vector because that's all being multiplied by t. And of course, this has the same form as the equation of our line. So it has the form R naught plus t times v. Now, this is going through a different point. We already have R naught, so I don't need this R naught. But it has to be parallel to this, so this has to be in the same direction, right? And remember, that vector gives me the direction. Let's make this clear. So this is the direction. And just make sure this is clear as well. This is plus t times the vector. So this is the direction that I want it in. I want it to be in that direction. So that is what I'm going to use for v. All right, so now we have R naught, we have v. It's going to be just like the first two. I do recommend writing this equation down every time you use it, so by the time you get around to the exam, you'll have it all memorized. So in this case, we're going to have the vector 1, negative 3, 4 plus t times the vector 4, negative 1, 0. Put all that together. R of t is 1 plus 4t for the first component, negative 3 minus t for the second component, and 4 plus 0t, which is just 4, for the third component. And there you go. All right, the final example here. Find an equation of the line segment joining the points 1, 0, 1, 0, negative 2, 1. All right, so this is going to be a lot like example 3, but this time it's a line segment. So let's see. First off, I'll go ahead and label that first point as P naught, which means that R naught is the vector 1, 0, 1. And just like before, to find V, I'm going from 1, 0, 1 to 0, negative 2, 1. So 0, 1, 0, or 1, 0, 1 is my first point. 0, negative 2, 1 is my second point. And so to find vector v, it's the second value minus the first value. 0 minus 1 for the first component, -2 minus 0 for the second component, and 1 minus 1 for the third component, which gives us a vector of -1, -2, 0. Okay, and then r of t, again, that is r naught plus t times v. In this case, that's 1, 0, 1 plus t times -1, -2, 0. So we end up with r of t is 1 minus t -2t and 1 for the last component. Now, we can't stop there. That's the equation of the line, but remember, we're trying to find a line segment. The only difference between a line and a line segment is that the line segment has restrictions on t. So, how do we find those restrictions on t? Well, we have to figure out, we're going just from 1, 0, 1 to 0, -2, 1. I have to stop at those. Those are my endpoints. So we know we're starting at 1, 0, 1, so our initial point is 1, 0, 1. Actually, let me just write this over here. So that means this equation has to hold true at that initial point. So what we can do is say that, all right, the first component, 1 -t, is equal to 1. The second component, -2t, is equal to 0. And the third component, 1, is equal to 1. So I'm going to have to solve this system. So again, notice where that comes from. I took the first component, the first component of my vector equation and set it equal to the first component of the point. Second component in my equation is equal to the second component in the point. The third component of in my equation is equal to the third component of the point. And if we solve this, we end up with t is equal to 0. And they all have to work for that. And they all do. So we're starting at 0 for our t value. And then if we look at the final point, we'll do the same thing. We're ending at 0, -2, 1. So again, I'll do the same little trick. The first component of my vector is equal to the first component of the point. Second component of the vector equation is second component of the point. And the third component of the vector equation is the third component of the point. So we have the system 1 minus t is equal to 0, -2t is equal to -2, and 1 is equal to 1. If we solve that, we get that t is 1. So we know t starts at 0 and ends at 1. So we'll need to jot this down. Let me put it here. This is for t between 0 and 1, inclusive. And there you go. Enjoy.